Welcome back to solving numerical problems from engineering mechanics, problem set 2.5, solution to 2.73. Thank you, Mr. Priyansu. Thank you, Mr. Priyansu, for asking me to upload 2.73 and 2.74. So let me read out the problem. A horizontal prismatic bar AB from A to B is a prismatic bar kept horizontally. Prismatic means all throughout it has the same cross section. It is given in the question the weight is negligible. The bar AB has of negligible weight. Its length is L. From here to here is length L. And this is a vertical wall. The prismatic bar is fixed to the vertical wall. Is fixed to the vertical wall here by a pin joint at A and supported at B by a tie bar. This is a tie bar. I will explain you what is a tie bar. Tie rod BC that makes the angle alpha with the horizontal. This tie rod makes angle alpha with the horizontal. A weight P. This is a load. Its weight is vertically downward. It is P. It can have any position anywhere between A and B. Means this can be here, this can be here, this can be here, this can be here. Its position from this end is given by X. So a weight P can have any position along the bar as defined by the distance X from this end, from the wall. Determine the tensile force S in the tie bar, in the tie rod, right? Now, what is a tie bar? They are deformed steel bars. As you can look here, this part is a portion of a pavement, this portion, and this is another portion. We need to join them. So you can join them as such, but if you join them with a tie bar, this is a tie bar, then it will improve the performance of the pavement, right? So what do they do? Basically, they improve the performance of the pavement joints. This pavement and this pavement can be joined along this rough surface, and if they are connected by a tie bar, the joint will be better, the performance will be better. Initially the cost will be more, but in the long run the cost will be reduced. So what do? They increase the initial cost but reduce the life cycle cost. So since it is a tie rod, so there will be axial force, tension force S acting from the point B to this side if you consider point B. If you consider point C, it will be acting to this side. Depends how you consider it. And if you produce P, the line of action of P to this side, it will meet at a point, let it be E. So the reaction force from A should also pass through the same point E for equilibrium. And it should be pointing from A to E, the reaction force. I will show in a different diagram. So let RA is equal to the reaction at A. S is the tensile force in the tie rod BC, pointing away from B to C for the point B, pointing away from C to B for point C. Now let the line of action of P and S meet at E. RA must pass through the same point E and pointing from A to E. Now, if you apply method of projections, it will be longer to solve. It will take more time to solve. But if you apply the method of moments that we have been doing in problem set 2.6, it will be much easier. So let us do it the general way, then apply method of moments. Now look at the diagram is redrawn for you. This is the line of action of P meeting S at point E. So the conclusion is the reaction force from the point E represented as RA should also pass through the same point E. Now, as you know, a vector can be shifted parallel to itself. If this is a force F, you can shift it here, you can shift it here, you can shift it here. So long as you don't change the length of the vector, which represents the magnitude of the quantity, and so long as you don't change the direction, you can shift anywhere in space if you like. So that is the property of vectors. So now, therefore, this S, which is pointing from point B towards C, I can shift this tensile force S parallel to itself and show it at E, pointing from E to C. And I can shift this load P parallel to itself, and show it at C like this, and this RA, no need to shift it. So why did I say so? Then you get a closed triangle. If you look at the triangle ECA, the side EC is represented by S by shifting this tensile force S parallel to itself. The side CA is represented by the load P by shifting the load parallel to itself. And the side AE is represented by the reaction force RA. So that is what I have written here. The sides of the triangle AEC is represented by three forces, that is EC by S, CA by the load P, AE by the reaction force RA at point A. Now, from the properties of vectors, that is the law of triangles, so P over AC will be equal to S over CE will be equal to RA over AE. So if you take these two things, then you cross multiply, you get S is equal to P times CE over AC, make it equation 1. We'll find out the value of CE and value of AC and we'll put it here. Then we'll find out S. So to find out CE and AC, we must look for triangles. So in triangle CFE, if you take cos of this angle, it will be base over hypotenuse. The base from here to here, that is same thing as from here to here, which was given in the question as x. So from here to here is also x. So cos alpha is equal to FE over EC, that is x over EC. EC is same thing as CE. So now if you cross multiply these two, you get x is equal to CE is equal to x over cos alpha, make it equation 2. And again in the bigger triangle, that is triangle BAC, right angled here, if you take tan alpha, it will be CA over AB. So if you take tan alpha, it will be CA, that is same thing as AC over AB. AC over length of the prismatic bar AB is given as L, right? So if you cross multiply, you get AC is equal to L times tan alpha. So we know AC, we know your CE. Now from equation 1, so AC is equal to P times, for CE I put x over cos alpha, and for AC I put L tan alpha. So just simplify it. So P times x over cos alpha times 1 over L tan alpha. Tan alpha will be sin alpha over cos alpha. Cos alpha will cancel. So we are left with S is equal to Px over cos alpha times L tan alpha. Tan alpha is converted to sin alpha over cos alpha. Cos alpha cancels. So S is equal to the tensile force S developed in the tie rod is Px over L sin alpha. So that is the answer. But if you apply method of moments, it will be faster. So let us apply method of moments. Moments about the point A. And let us see which forces will have some turning effect about point A. Now, obviously, the reaction force. Look, this reaction force RA is passing through the point A, means RA does not have a perpendicular distance point from point A, so RA does not contribute any turning effect about point A. Now this P will contribute a turning effect because the P has a perpendicular distance x from point A. So P times x will be a clockwise turning effect about point A. Then if you look at S, if you split S into two rectangular components, one along this will be your S cos alpha, and S cos alpha is passing through the point A. So S cos alpha does not have any turning effect about point A because this S cos alpha, which is a component of S, this does not have a perpendicular distance from point A. But this component, this one, that is equal to S times sin alpha, this will produce a turning effect about point A because S sin alpha is at this perpendicular distance, that is from here to here, that is equal to L. So this will produce a turning effect. This force S sin alpha times this length will be an anti-clockwise turning effect about point A. So if you apply method of moments about point A, only two forces are producing turning effect, that is P and S sin alpha. One is producing a clockwise turning effect and this one is producing an anti-clockwise turning effect about point A. So that is what I have done here. So P times the perpendicular distance from point A is equal to S sin alpha times the perpendicular distance from point A. So keep S on one side, take rest to the right hand side, it gives Px over L times sin alpha. Same thing as we did it here. So thank you, Mr. Piansu, for asking. 2.74, I'll take some time to upload. If I get time tonight, I'll upload, maybe on tomorrow. Definitely. Thank you. I hope it is clear to you. The method of moments is very important because it solves the numericals in less time. So I would request you to follow method of moments rather than solving individually in the different, rather than finding the components, then finding the sum equal to 0. So, okay, thank you.